Hi, Sterling Allen here again at the TeslaTech, doing part 2 of this interview with Dan Glover on the Inteligentry technology, the noble gas engine. Sorry about my battery dying on that last part 1. So here we go with going into a little more nuts and bolts of the technology. Okay, Dan?
Yeah.
Hi, Sterling. Okay, so I'm going to go over a little bit about the technology behind this do-it-yourself device and then talk about a little bit what we're providing in the kit. All of this stuff here is public domain, so keep that in mind. There's nothing magic, secret here. This is an evolution of the old Joseph Papp engine. Now, he used radioactive materials. He had a lot of stuff going on there that modern technology, we don't need to do that stuff. We're a little bit more responsible. This is kind of fun, do it at home. So let's go over a little bit about what happens here. We're actually missing a coil, so use your imagination and pretend there's a longer coil here covering up the cylinder. As part of the kit, you actually get both coils. This is a high compression coil, and the other coil kind of can think of it as a magnetic containment field. So let's talk about how we turn a noble gas into a plasma. First, the cylinder is loaded with noble gases, and in this particular device we have little valves coming on this side, and we have a valve coming out this side, and we actually have something pretty crude, a balloon, like a kid's balloon, that kind of tells us when the helium is running out. So when the chamber is filled, the very first thing we do is we begin the containment fields. This coil here contains it in place. This coil here squeezes it. Now, we've actually got a noble gas mixture here, and this is very, very similar. I think it's in fact identical to the original Papp patent. But what it is a mixture of heavy inert gases all the way down to helium, which is the lightest. Now, when you compress these gases in a coil, the helium tends to react the most because it's the smallest. It'll go towards the center. The argon and the heavier atoms sort of align themselves on the outside of the coil, creating a buffer. So when we squeeze, it's not only getting it closer to that plasma state, but it's also getting everything lined up just how we want it. Once we begin squeezing, and the goal here is, I don't know if Alan can zoom around, the kit we send only has 2. This one has 4, much like our reference engine. But the goal is to get the helium to line up on the other side of this center. You know, it's almost like a little pinhead. This is what we want everything to arc over to. It's a welding rod. When these things spark, they all spark towards the center, and they form a little ball of lightning. But first thing we do is we hit it with the compression, it squeezes it down, and then we burst a short RF, radio burst, kind of like a microwave oven. The frequency we've got written down here on this brochure. If you're a CB guy, it's just AMO channel 12. Very short burst, and what that does is it excites the noble gases into an even higher energy state. So now we've got it compressed, now we've got it brought up a little bit higher in energy with the radio frequency, and then we nail it with a high voltage. This right here is 400,000. The actual kit, you don't need that much for. We send 2, that's 200,000 volts. So doing these 3 things in conjunction, we squeeze it, we bring it up to a higher energy state with the radio frequency, and then we nail it with energy. All those things working simultaneously begin the plasmic transition. What happens there, and kind of at the very tip of this, is you get a plasmic waveform happening. So you have this ball of plasma, primarily composed of helium. It begins expanding out. Now, we've got a containment field here, and plasma is very, very good when it's contained in a field. So none of the plasma wants to hit the outer walls. It's all focused right on the piston head, which is, in this demonstration, it's right here. So you've got the wavefront, it pushes the piston head out, and this particular mix of gas expands at about a 5-to-1 ratio. So if you have an inch of gas in the cylinder, it's going to come out about 5 inches when it's done. Once it's done, once we've got that plasma fired, it shuts off. When it shuts off, the plasma now no longer has the energy to maintain that plasmic state and just collapses back into the original gas, creating a little bit of a vacuum, which in most cases will pull the piston head right back into its initial position. From there, we provide a small electronic board, which acts as a repeater. It's got a little dial on it that you can turn up the speed, turn it on and off, and the goal here is that you can get it going, pop, 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 over and over again. It's not actually loud. Sometimes you've seen these devices and they actually make a loud noise. When it runs, it's actually, you just hear the mechanisms inside, the electric inside. If it begins making a lot of noise and drawing too much power, you know you've got a bad mix of air. You know you've got atmosphere in there, because when it's like lightning. Lightning's very loud. When this thing happens, it happens at such a fast, billionth of a second. You see the push, it collapses back. It's actually quite a quiet system. In principle, that's how it works. Now, the coil windings, the radio frequencies, all the stuff is out there. And if you were to read through the patent, he's actually got a lot of stuff in there to confuse the inventors. He was a very paranoid man. He didn't like people figuring out his stuff. He was afraid that people would steal it if they knew how simple it was. So what we've done is essentially, we're not really so much selling the electronics. We're providing that because that's the intimidating part. But we're really kind of selling you time. We've taken our experience with these devices and kind of organize them in a manner that you can build one of these devices at home. We're providing the ignition coils, we're providing those modified spark plugs, we're providing the 2 coils already wound, the wires that connect everything. We're going to give you the designs and kind of pointers on how to build this encasement. You don't need to do it out of Lexan, you can do it out of aluminum, you do it out of a lot of materials, because remember, there's very little force because of that containment field. There's really nothing hitting the outside wall. There's no heat being generated because it's happening so fast. So the only thing you really have to contend with is keeping the gases hermetically sealed. And we'll go over some practices that we've learned in our instruction manual. We'll also provide the circuit diagram for the little control board. If you're electronics folks and you look at it, you think, I get it, this is no big deal. No, it's really not a big deal for this. To get a 1-cylinder engine going pop, 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 it's really not a big deal. But what this will allow you to do is you'll be able to prove the technology to yourself. And once you see the enormous amount of force behind the plasmic transition wave, you'll realize that, okay, well, we've got more force here coming than what's getting put in. If I was to do this in an engine environment, it would look something like this. And so once you start thinking about what you would need for those electronics to actually build a consumer product, the diagnostics that you would need, what you would need to get this running up to 1800 RPMs, and no, the demonstration unit won't be going that fast, you'll realize what we bring to the table in this new technology. This stuff is public domain. None of this is magic. All of this stuff you can play with at home. Please do. If you do it, by all means, send us a video. We'll post it on our website. We want to get people out there playing with it because, quite frankly, we're only into this a couple years. And
tell us your website.
Plasmic.com or Inteligentry.com.
Inteligentry with 1 L.
With 1 L, that's correct. That's John Rohner, the inventor's website. It's kind of like his blog. Plasmic is the electronics company. We're going to be redoing these websites over the few weeks, but the Inteligentry stuff will always be John's. So he posts on almost a daily basis there. It's kind of fun. But the idea is this is all open. This is actually what we use to create this, in that in the beginning days we tried different windings of coils, we tried different radio frequencies. Each one of the 3 elements that form the plasma can form plasma on their own. If you have a strong enough coil, a crazy strong coil, you can form a plasma. If you have a strong enough radio frequency, you can form a plasma. If you have enough voltage, you can form a plasma. The idea is, however, doing it efficiently. And this combination of these 3 things allow us to do it at, even though it is high voltage, it's a very quick pulse. And overall, the system doesn't need that much. You can run it off a car battery, but the kinetic force it produces is phenomenal. So go home, play with it, measure it, send us your results, have fun, and who knows, maybe you'll even be able to improve on what we've done, because by all means, we don't know all the ins and outs. There's a lot of mysterious things going on here. And when I say mysterious, there's some coil windings here that will burn through the gas much faster. If you use the original PAP one last year, Sterling had an interview with John Rohner. I think that's on YouTube somewhere, where John Rohner talks about the Plasmic anomaly. That's if you go off the original PAP, you follow his instructions, and you realize what a devious little guy he was, in that he purposely did that to screw with people. So that if you were to try to replicate it at home, you'd screw it up, you'd be like, this will never work. Well, we've gotten through all that stuff. we've done some testing, we pulled together other scientific articles, and we put it together, and we're going to save you time to do this because this is all public domain. There's no reason why anybody should have to go through the year that we had to go through. Because once you see this going, you'll realize that engines are real. It's not a matter of if, it's a matter of when, how the plasma is formed, and who's going to bring it to market first. And we're here to try to bring it to market first, quite honestly. We've got the electronics expertise. John Rohner's been in the electronic industry for probably 40, 50 years. He's got a ton of inventions under his belt. This is what we bring to the table. This here, what you see, is a school engine. As part of the PTP licensing process, if you want to become an engine manufacturer or you want to become a product manufacturer and work with this new technology, what we do is we sign you up as a licensee. We bring you in, this is Mark Kaufman, our chief instructor. In order to finish the license application process, you come and you take one of his courses. And one of the courses we offer is an engine lab. 3 days, we give you a box of parts, the controls, the gas. Over those 3 days, you put this thing together piece by piece. We fuel it, we get it running for you, and you take it home. And if you're not happy, you don't pay your license fee. And so part of our licensing process, which we're going to be opening up, we hope our manufacturers willing, end of August, September. We're going to be starting with the larger licensees first because, you know, as Tana puts it, if we don't have engines, we don't have the ability for product manufacturers to buy the engines. So we're going to start with the engine manufacturers first, work our way down to the product manufacturers. If you end up licensing, you're going to be taking a class with Mark. Depending on the level of license you take, it might be a 1-day class, it might all the way be up to a 6-day class. Any of the licensees have the option to take the engine lab course, which allows you to build what you see here, power it up, get it running, take it home with you. That's part of the license application process. Now, we don't sell this to consumers. We don't ever intend to be engine manufacturers. What we do is we produce electronics, and the majority of our intellectual property and our beliefs around this technology is this is public domain stuff. However, to get it to run at a efficiency and a timing and diagnostics that a consumer product is going to need, that's where you need advanced electronics, and that's where John Rohner comes in. So as a company, we're not trying to tell you that this is secret proprietary stuff. In fact, we made the business decision to unveil a little bit of our learnings and help you build one of these at home because this is public domain. There's no trade secrets here. This is just our pain and suffering, figuring out how to get it to work. So we're going to share that with you because it's not patentable anyways. Go have fun with it. Build us, send us what you learn, and if you come up with a new discovery, well, we're excited. This is a new field of science. We want to help the community learn because it only helps us in turn. Not only might we learn something from the folks out there, but also it kind of takes the heat off of the business decision we made where we're not going to be showing this running. In fact, when this goes public, it's not going to be us showing it. It's going to be us in conjunction with our manufacturers. So if we wind up getting a manufacturer who does a portable generator and he wants to go to the press and the community is ready, that's going to be our press release. It's going to be that manufacturer. We'll stand behind them as the inventors, as the intellectual property holders, but we're not going to be manufacturers of engines. We're electronics guys, we're research and development guys, we're geeks, we're scientists, but we're not engine manufacturers. And so once you see this running and have fun with it, then anybody who sees this thing going, and when we get back, we're going to get this going and post a video of it kind of popping along. Once you get it going, you'll understand that this is just a matter of time and research and development and know-how, and go for it. Attack it, have fun with it, see what you can make out of it, and if you do come up with something great, send us a video. We'll be happy to post it on our site. We'll be happy to comment if you run into problems, email us. We'll be happy to help you troubleshoot. So what the kit contains is the 2 coils, 2 of the ignition, the modified spark plugs, the electronic control board, which we don't have here, but it's going to be much smaller and kind of dumbed down version. We're going to provide the circuit diagrams, detailed drawings over how this was made, and as well as just kind of our instructions and tips, which is really what you're buying. Is we're going to simplify all the crap that's out there, tell you what worked, tell you what hasn't worked, and that way you can kind of get a leg up on trying to do this yourself and proving it to yourself. I think that's it. We hope to hear from everybody, and even if you don't wind up buying our kit, and if you end up doing it, go ahead and post it. Send it to us, let us know, because we're really fascinated about everything that people are coming up with.
Well, but the manufacturer.
Okay, thank you. Appreciate it, Dan.
Thank you, Sterling. Helium, which is the lightest. Now, when you compress these gases in a coil, the helium tends to react the most because it's the smallest. It'll go towards the center. The argon and the heavier atoms sort of align themselves on the outside of the coil, creating a buffer. So when we squeeze, it's not only getting it closer to that plasma state, but it's also getting everything lined up just how we want it. Once we begin squeezing, and the goal here is, I don't know if Alan can zoom in and talk about a little bit what we're providing in the kit. All of this stuff here is public domain, so keep that in mind. There's nothing magic, secret here. This is an evolution of the old Joseph Papp engine. Now, he used radioactive materials. He had a lot of stuff going on there that modern technology, we don't need to do that stuff. We're a little bit more responsible. This is kind of fun, do it at home. So let's go over a little bit about what happens here. We're actually missing a coil, so use your imagination and pretend there's a longer coil here covering up the cylinder. As part of the kit, you actually get both coils. This is a high compression coil, and the other coil kind of can think of it as a magnetic containment field. So let's talk about how we turn a noble gas into a plasma. First, the cylinder is loaded with noble gases, and in this particular device we have little valves coming on this side, and we have a valve coming out this side, and we actually have something pretty crude.
Hi, Sterling Allen here again at the TeslaTech, doing part 2 of this interview with Dan Glover on the Inteligentry technology, the noble gas engine. Sorry about my battery dying on that last part 1. So here we go with going into a little more nuts and bolts of the technology. Okay, Dan?
Yeah.
Hi, Sterling. Okay, so I'm going to go over a little bit about the technology behind this do-it-yourself device, and a balloon, like a kid's balloon, that kind of tells us when the helium is running out. So when the chamber is filled, the very first thing we do is we begin the containment fields. This coil here contains it in place. This coil here squeezes it. Now, we've actually got a noble gas mixture here, and this is very, very similar. I think it's in fact identical to the original Papp patent. But what it is a mixture of heavy inert gases all the way down to